Hello everyone and welcome. In this video I will start a new exciting project where I will hook up my energy meter. It's using a HON port interface or a P1 interface. It's the same type of connection. And I will use an Arduino to gather the information and then of course upload it to my Magic Mirror and show some nice information about my energy consumption. Welcome and hope you enjoy. Let's have a look at the interface, the HON port on the energy meter. The energy meter actually has a 5-volt supply that we can use for supplying the interface logic, in this case the Arduino. It also has an optocoupler for the data traffic with an open collector. So before we can test this, we need to do a few things. First of all, we want to tie the ground, the logic ground and the power ground together. And we also want to enable data transmission. In order for the energy meter to transmit any data, we need to tie the data request to 5 volt like this. And then we will also supply the logic with 5 volt. And the data output going to the logic, so then output. And we also want to have a resistor since it's open collector. See if I can draw it. We need to tie a resistor to the data signal. In this case, I will just use a 1K resistor for testing. So this is what we need to do. Let's try that out. Since it's an open collector output, I connect a small resistor 1K. I also want to enable the output, so that's why I got this one. Then we want to hook it up to the oscilloscope to see that we get the signal. Since you need to talk to your energy company and let them know that they should activate the HON port, I want to make sure that we have a signal. And yes, indeed we have. So we can see it's sending information, and actually it's sending part of the information frequently with a few seconds in between, and then it's sending all the information a bit more infrequent. So good, we have a signal. Next step will be to hook it up to an Arduino and actually read a message and see what the kind of information we have. I like to use the Arduino Nano 3.3 volt IoT. It's a small and nice device. It has all the functions that I need. It has a Wi-Fi and it has all the IOs I need and serial ports and so on. So I like to use this one even if it's a bit on the expensive side. I made a small schematic on the interface here, and as you can see I have tied the data request to 5 volt, and then I use the 5 volt to feed the Arduino as well. And the Arduino is a 3.3 volt, but it will convert the 5 volt to 3.3, and it will also supply 3.3 volt to the rest of the logic. I've connected the data ground and the power ground together, and together with the Arduino ground. And then we have the data coming in at pin 5. I use a 1K pull-up resistor since it's an open collector. And then I use a PNP transistor to invert the signal since I need to have it inverted in order to be
correct into the Arduino serial port. So here we have the inverted signal, and it goes directly into the second serial port on the Arduino. I've also added some other things here that I like to have on my small IoT devices. One is the temperature sensor. I use a Dallas R18B20. Usually very good temperature sensor, and it also needs a pull-up of 4.7K here. And then I bring it into the either one of the input ports on the Arduino. In this case, I've also added an interface for display, a small display. Always good to have some kind of indication on the devices. Good for debugging, good for seeing that everything is running like it's supposed to. So I will use it or not, but I have it ready if I want to have a display on the device. So very simple. This is it. The next step will be to build this on a PCB board. Let's go ahead and create the small test program for the Arduino so we can see if we can connect to the home port and get some result back from it. As you can see, I'm using Visual Studio Code here as well, and I have the plugin for it's called let's see, PlatformIO. And that's really good to use for programming the Arduinos and the Arduino devices. I will go into that a bit deeper in the next video where I look into the full code of this energy meter. But for now I will just create a quick test program so we can see that we get some data from the on port and what type of data we get. So first I will just set up the serial port. So I can print the result on the console. And then I will set up serial 1, which is the secondary serial interface on the Arduino Nano. And the speed is the same. Maximum serial speed on the on-port interface. And then we want to check if we get any data back. See if there are any bytes. And if we get something back, we want to read it. If there are any bytes in the buffer, I will look for carriage return. Let's put it in a string variable. This. And then let's print the result. So that will basically read anything in the buffer until it finds end of line and then print the result onto the console so we can see it down below here. Let's download it to the Arduino. Just make it a bit more easy to read. And then we download it. And then we connect it to the home port.
So it's all hooked up. The small PNP transistor to invert the signal and going into the RX on the Arduino. And if we have a look at the console, you can see that I'm actually receiving values here. And it's in clear text, so that's really nice. But it works. Okay, so let's hook it up. I found one more track that I hadn't broken up, so I had to do that. Otherwise, we can see it's, you can see the LED is on, so it's getting 5 volt from the interface. We can also have a look at the signal. Yep, getting a signal in. And we're connected to the computer to see if we can get some data in. Yeah, success. It works. That's good. Then we can continue.